Oh, yeah. So the manager. Okay. Also, we need to get manager.address, and then we run that, and voila, we have something here, right? So this, this H1, just to make sure you understand as well, this H1 here is what is showing here, and then the output of this contract. So SmartPy gives a nice output of the H contract and of this contract, and there's the output of the contract. You see it outputs the code of the contract, and then it also outputs the storage. So when you look at the contract storage, and so this is here because of this plus C, right? Because we are adding this contract to this to the scenario, and this basically this side is what is called the scenario, right? And so when you look at this carefully, you can see that whatever code we have here is what is also here, and then this is the registrars, okay, and then there's the manager. So let's go here, and then you can see this is SmartPy. This is the types. So when you look at the storage, the manager part, right, is stored as sp.t address. So in SmartPy, all the SmartPy types. Okay, so when you go to type in the SmartPy, you go to just go there, and so all the types are represented as sp.t something. So if you have boolean, sp.t bool, integer sp.t int, is NAT is natural number, sp.t nat or non-negative numbers, and sp.t int or nat. So sp.t string, you see, you get the idea, right? So we have something called Tezos specific. So this is related to Tezos itself, and you see that because Tezos is a blockchain, and that is where we get the addresses and all of that. So sp.t address, right? So this is an example of, I think I've not shown you a Tezos address up to now. My bad. So this is an example of a Tezos public address or public key hash, right? So it starts with TZ1. Sometimes you have TZ2 or TZ3, and then we have the rest of the stuff here. I mean, if you want to know more about this stuff, you can visit this site, right? Tezos.gitlab.io. So when you visit Tezos.gitlab.io, you can know more Tezos specific types stuff. But most of this stuff, you don't really need to know to write smart contracts, right? You just need to understand what's the difference between these addresses and all of that, and that's it. So and also when we look at, see, we have the storage, and then we have the entry point. So entry point, we have add registrar. So this entry point is going to act like an endpoint or an API endpoint, and then later you're going to see that we can call this entry point directly and say, oh, okay, I want to call add register entry point, and I'm calling with this that, and you can interact with the smart contract, not the whole smart contract, but just an entry point on the smart contract, right? That's nice. So also when you come here to deploy microsync contract, you can actually deploy the contract from this place, and we will do that very soon. Just now we'll do it. Before we even continue with the rest of the application, we'll just add a few. After we define this remove registrar, we'll do that. And so you see the storage, it tells you that how many bytes are we using in the storage. The code is taking 234 bytes, and the combined everything is taking 405 bytes. So the storage is taking 171, and the code itself is taking 234 bytes, and everything combined is 405 bytes, right? And the reason why this is important is because you are charged, right, for the storage on Tezos, right? So the storage goes for this much. 1 byte is, so let's open the calculator, all right? So let's say 1 byte, right, is equivalent to 0.0001 Tezos, right? And 0.001 Tezos, so 1 Tezos is $3, right? So 0.001 Tezos, that will give us $0.003, right? And so let's say if your code is like, and your data, everything gets to 1 kilobyte, then we have times 1000, so that's $3 for one kilobyte of payload over here, you know. So if something which is 1 kilobyte, it means you have $3 cost. Right? And this is going to increase as the value of Tezos increases, because the cost of storage is stated in Tezos, not in dollars. So at first it was 0.001 Tezos, and at first, right, it wasn't a problem really, because at first 1 Tezos was like $0.9, right? 1 Tezos was like $0.9, and in just like a few months now, 1 Tezos is what, $3. And so you see that the cost of storage also increases, right? Good. So yeah, so that's one of the things you should note, that your smart contract doesn't have to store a lot of things. You have to be very strategic when it comes to using smart contract to store the stuff, right? Good. So when we look here, we see the storage of the smart contract. This is Michelson, and we also see the code, right? So this SmartPy that we've written here has been compiled into this code. I mean this place, right? I'm talking about this part. This part is just for testing, so it's not part. But whatever is here has been compiled into this Michelson code over here, right? And Michelson code can actually be also converted to JSON, has a JSON format, right? So whatever is here, this is the JSON format, and whatever is here, the whatever is here, which is Michelson, this is a JSON format, right? So let's go back to SmartPy, and we see a nice visual or something. Also, before we try to add, define, remove registrar, let's try to invoke the add registrar function, right? So who can add a registrar is the manager who can add a registrar. Right now we already have 3 registrars there. So let's say we want to create a scenario. We want to add to our scenarios, that's h2, let's say add registrar. So right, so let's create the 4th registrar 4. So we assume that output to this point we have deployed the contract, and now we want to call the add registrar endpoint of the contract to add registrar 4, right? So R4, and so what do we do? The contract is C1, is C, right? So we just say, so instead of we just say scenario plus equals C dot add registrar. So you know, in this scenario, anything you append here will be appended here, right? And so I'm just calling this contract, I'm just calling this endpoint or this function in this contract, which is just a class, right? So don't let your mind go far. In fact, this is just a class. And so add registrar, and then the add registrar, I need to, you see this params, as I mentioned, we can get all our data from here. And so whatever I say here, as maybe if I say registrar, right, is equal to r4.address. Remember we had an error with that, right? It's going to, that is what is going to appear here, right? So if say I'm to define something else like land is equal to something, then I can access it here as params.land, right? So if you want to get something from params here, you have to explicitly state it here and then equals the value, right? So I get you, you get what I mean, right? So this is the endpoint add registrar, and now we can't finish it, so we say dot run. So when you go to the reference manual where it gives you the text tools, tools for testing, right? To call, you can call an endpoint, and then you can say dot run, and then you can specify the sender, the source, the amount, and now the valid, and all of that. So right now, let's say we are interested in the sender. Okay, we'll look at the other ones later. So dot run sender equals manager, right? So what it means is that in here we are simulating that the person sending the contract is this manager, right? This is the manager we used to initiate this contract. So this manager already exists here in this contract, right? And so now let's run this and see what happens. So when we run this and see, you see that we can now scroll here because more has been added, and we can see our H2 that we added here is a add registrar, and then so this is saying we call the add registrar function, and then we pass it this parameter registrar, who is like just the address of the registrar. And so you can see that now the registrars, initially there were 3, now the storage has increased to 4 registrars, right? And the manager is still the same thing, the same manager here, right? So let's try something else. So instead of calling the add registrar with so let's just call add registrar here, and just copy and paste here, and let me just copy and paste also this, right? Add registrar with wrong manager, and I say registrar 5, so registrar 5 dot address, and I say run sender equals, maybe let me create another manager and call that person wrong, right? So wrong, let me say just wrong. Okay, just wrong is fine, and I say wrong. Okay, so let's see what happens when I call this. We get a pop-up, right? And what is the pop-up saying? It said unexpected error in transaction pre-use. Okay, fine. So you say dot run valid equals false, so we'll come to that. It said wrong condition in line 15. You see, this is line 15, and this is where we are doing the verify equal the sender is equal to solve the data dot manager, and say unauthorized account, you're not manager, right? So we know that this is supposed to be wrong, right? We know that this is supposed to be invalid, because this line because this add register function has to be called by the manager, right? Or has to be sent by the manager. In this case, we are not sending it with the manager, we are sending it with a different account. And so we know that this has to be wrong, and so we have to say that valid, in order to prevent the pop-up from showing, we say valid equals false, which will not let SmartPy know that we are expecting that this one will be a false. So now let's run it again, and nothing pops up. But when we scroll down, we see that this is in red, which means that there was a wrong condition on line 15. And when we go there, it said unauthorized action, you are not manager. Why? Because we are calling this with the wrong sender. And you realize that when we deploy this onto Tezos blockchain itself, and we don't call with the correct manager, it will give us a invalid kind of result. Okay, so so now, so basically what we have here is some cool authentication without even doing anything, right? So the manager is a person who has a private key of this manager guy, and that is the only person who can call this add registrar. And so by remove registrar, I'm sure by now you have an idea of how to do the remove registrar. So let's just say something. So you say something like this, right? And then we say self.data.registers. We can just copy this, but now with sets you can call something called remove, and you can remove an element from the set. So dot remove, and we can say params.register registrar, right? And so we have also added the remove registrar command, and so by now you are familiar with this, right? So let's test that one too. So remove registrar, we know that only the manager is supposed to be able to remove registrar. So first of all, let's call the remove registrar with the correct manager, and then later we'll come and call the remove registrar with the wrong manager, right? So remove registrar, we are going to remove registrar. That's a mosquito disturbing us over here. So, and we have change this to remove, and then we want to remove registrar 1, right? So note one of these registrars will be removed, and then we are going to send manager. Yeah, so let's run and see. And yeah, you see, so from the start we had 3 registrars, and then we called add registrar, and then we added this registrar, right? And then we intentionally called a remove add registrar to run manager, so it should give us an error. If next time we are doing this and we don't get an error, it means that there's something wrong with our code, and we can go and change that. And we call remove registrar, removing this guy TZ1 gene A gene Z. So when we come here, we can see that we have TZ1 gene A gene Z here. This is apparently registrar 1 because it's not necessarily in order, it's a set, so it doesn't have to be in order. And now we have 3 registrars. Yes. So let's do this. You need to do this, just remove registrar with wrong manager, right? So once you do this, in case you end up changing, you know the importance of tests. So this is just these are just simple tests to ensure that you don't mess up your code. So scenario.remove registrar, and then we say we are going to use the wrong manager, right? And let's try to remove registrar 2 since registrar 1 has already been removed. Oh yeah, so we are expecting this to be false, so we say valid equals false, and then yeah, so when we scroll down we see remove registrar, right? Unauthorized action, you are not manager. Good. So wrong is not manager. Whew. So that is the initial part of this contract, right? So now we have a registrar who can add managers and remove we have a manager who can add and remove registrars and all of that. So this manager will be in charge of the contract itself, adding and removing registrars and this and that and this, right? Okay, so hopefully this will demonstrate to you like the use. All right, so this contract is good enough. We can launch this contract on the Tezos blockchain, but we are going to launch it on the test net. So yeah, when we come here we can see storage code. You can see now the code has increased in volume, all of that and all of that, lots of things. So these tabs are not really apparent, but so deploy microsyn contract. So when you click on deploy microsyn contract, it will take you to a different tab, and with this tab so Tezos has, at any point in time, Tezos has 3 networks running, right? So one is mainnet, one is cartage net, and then one is zero net. I don't know what this lab net is for, but mainnet, cartage net, and yeah, something. Anyway, so mainnet, cartage net, and zero net. So I'll explain to you what this mainnet is. So mainnet is the main thing that's the actual Tezos blockchain, right? And over here, whatever you do actually costs money. I mean, this is where like the Tezos crypto has value, right? And then cartage net, also known as test net, because previously it was called Babylon net, right? So the reason why it is called cartage net, even though it's actually referring to the test net, is that currently Tezos is running on a protocol called cartage, right? So Tezos is able to upgrade itself to new protocols, and the current protocol that Tezos has upgraded itself to is called the cartage protocol. And so the test net for that cartage protocol is the cartage net. Now on this cartage net, I mean, that doesn't matter, but the important thing is that on this cartage net you can play with anything you want, all the Tezos you want and all of that, and you can actually get free Tezos and all of to play with, and it doesn't have any value. Like, it's just a place where you can, it's just a playground, which is also like a blockchain network on its own. I mean, but it's just a playground so that you can test your applications there. If your application works on the cartage net, that means if you deploy it to the main net, it will work there, right? So right now we just select cartage net. Good. And then you're asking us, because we say we want to deploy a contract, right? And in Tezos terms it's called origination, direct network contract origination, right? So we are going to originate this contract onto the cartage net. We could have originated to mainnet, but we are just playing with it, so we originate to cartage net. We test it over there, and then once everything is working well, we go to mainnet. But for now, cartage net. And then to be able to do anything on Tezos, actually you need a Tezos account, and by Tezos account I mean you have the Tezos public key hash, you have private key, and then you have public key, right? So actually let me see if I can find if I can find something here for you. Okay, so these are okay, so